Hello and welcome to Linear Models. Linear basically means line. So anytime you see the word linear, you should be able to pick out the word line and know that means that something is going straight. Linear functions model situations that grow by equal differences. So it's going up by the same amount each time, which makes it a straight line over equal intervals. So if the interval is the same, it's going up the same amount all the time. It's not going to curve and go up less and then go up more. Linear functions are increasing or decreasing at a constant rate, not an increasing or a decreasing rate. Remember, we can represent that with the formula y equals mx plus b. M is the slope and b is the y-intercept. This is called slope-intercept form. So what we should be able to do is draw the graph of y equals 2x minus 3. From looking at this form, the m here is the 2. And the b here is the negative 3. So remember how to graph this. We would start at negative 3. That's where it crosses the y-axis. And the slope is 2. We would represent it as a fraction. 2 is the same as 2 over 1. So it's going up 2 for every 1 that it goes to the right. So starting here, it goes up 2 over 1, up 2 over 1, up 2 over 1, and so on and so forth. And here I can draw to connect my line. Now the common question though with something like this is, what is the x-intercept? Meaning, where does it cross the x-axis? And on here it looks like it's right about there, but we don't know exactly what number that is. It's either between 1 or 2. So the way to find that number exactly, it looks like it's 1 point something. The way to find that number exactly is just think about our table. When y is 0, that means it's not has a height of 0, and we want to know where is the x when y is 0. If I go to my original equation and think, what if I plug in 0 in for y? This would then help me to figure out what is x when y is 0. So to get x by itself, I could add 3, which gives me 3 equals 2x, divided by 2 on both sides. And that is 3 over 2, which is x, which is 1.5. Oops, come on. Smartboard is a little bit slow responding here. Not so smart, are you? So, when y is 0, x is 1.5. We can always find the x-intercept by letting y be 0. We can always find the y-intercept by letting x be 0. So this is crossing right at 1.5. Okay? A couple of examples here. Allison opens a savings account, very smart, by depositing $500. She plans to add $125 to the account each month. So the question is this $500 the amount it's going up, or is it the starting amount? Hopefully you can realize that is the starting amount. So that is our B term. That is where it's crossing the y-axis. That's our beginning amount. And then the slope, it's going up $125 each month. So an equation to represent that is y equals the slope, that doesn't look like a very good 2, the slope x plus 500. Thinking about it on the graph, she's starting at 500, it's a pretty good starting point in month 1, or month 0. And then after 1 month, she puts another $500 or $125 in, so now she's at $625. And the next month, she's going to be at $750, and it's going up $125 each month. This models a linear situation. It's going up at a constant rate. Okay? What if we're given 2 points? Can we find the equation if we're given 2 points? We've got 3, 7, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and 9, 9, 9, 9. So we've got this line here, and we need to find the equation of it. So we need m, and we need b. Now the m is fairly simple. We could try to count on our graph paper, rise over run, or you also hopefully remember the slope formula. That is x1, y1, x2, y2. The slope formula says y2 minus y1 over x2 minus x1, which is going to be 2 over 6, which is 1 over 3. Does that match Going up 1 over 3, up 1 over 3 looks pretty good. So the slope is 1/3. Well, what about B? What about the y-intercept? It looks like it crosses right about there, but you can see my line is kind of not particularly straight. I wouldn't trust it completely. What you can do, though, to try to figure out B, is think about this relationship. Y equals mx plus b. We have an m, 1/3. We can plug that in. We have an x. We could use one of these x's and y's. Here's a 3 for x. Let's plug in the 3 in for x. We have a y that is 7. We'll plug that in for y. And the only thing we don't know is b. Now we can figure it out. 1/3 times 3 is 1. Subtract 1, subtract 1. 6 is equal to b. Hey, it looks like my graph was pretty good. 1, 2, 3, 4, 5, 6. So to write my equation, I've got an m and a b, so y equals 1/3 x plus 6. Okay? One example for you to try. Check in your notes, try this one, pause the video, see if you can do it and get it right, and then restart it and hear the answers. Pause, and play. Here we go. We've got these 2 points, negative 1, 4, 1, 2, 3, 4, and 5, negative 2. I need to find the equation here. So first let's find the slope. y2 minus y1 over x2 minus x1. Okay, this is going to be negative 6, and this is minus a negative, be careful, plus a positive. That is positive 6. And negative divided by a positive, that's going to be negative 1. So it looks like it's going down 1 over 1, down 1 over 1, down 1 over 1. Pretty good, there's my slope. Now to find b, remember I start with y equals mx plus b. I could use either this x and y or this x and y. It doesn't matter as long as I don't use an x from here and a y from there. So let's go here. Here's my x. Here's my y. I need an m, I got that from over here. And I just need my b. So 4 equals, this is 1 plus b, minus 1 on both sides, and I get 3 equals b. So my final equation, y equals, it's always going to be something x plus something, it's just what goes in there. Y equals negative 1x plus 3. Starts at 3, goes down 1 over 1, down 1 over 1, down 1 over 1. Linear models. Have a great day.